if you don't have the display yet, let's just take a look at a couple numbers. 12 and 8. What's the greatest common divisor, the GCD, of 12 and 8? 4, right? And so, you could say, well, for sure it's 2, but 4 is going to be the greater divisor. So, if we call this 4, does 4 divide into 12? Does 4 divide into 8? Okay, so when we look at greatest common divisor, you are saying that D, the greatest common divisor, divides into A and B. Now, I think this E that they're talking about has to do with showing that it's the greatest, because 2 does as well, but it's not the greatest, so this is repeated until you get the greatest one. But the main thing you would need to remember is that this divisibility, super helpful. And when we have D divides A, which is the larger, A or D? A is the larger, so we can say that D is equal to A is equal to DK1, and B is equal to DK2, where K1, K2 element of the integers. Remember that? That part's okay? So that's kind of the gist of the first one. And you can see how greatest common divisor of this gives you 24 and 36. 12 is divisible by both. How about 12 and 0? 12 will divide 12. Can you take 0 and divide by 12? And get an integer? Yeah. So that's why 12, 0 is 12. 15 and 28 do not have a greatest common divisor except for 1. So this is what we call relatively prime, is when the GCD of A and B are equal to 1. And so the next theorem actually makes a lot of sense, is they're saying if D is the greatest common divisor, then if you took the greatest common divisor of A over D and B over D, what will that be? Well, let's take this. What was 12 over 4? 3, and 8 over 4. What's the greatest common divisor of 3 comma 2? There's your 1. So that's an offshoot or a result of that. And another thing that we want to add to the relatively prime thing is that we can add a value C, take A plus CB, comma B, and we can equate these two. And this one will seem weird at first, but it'll make more sense. Now I think this section is a little confusing. It's got a whole bunch of properties to it and a whole bunch of theorems to it, and it's hard to distill what's the most important. And so I'm actually going to do that by helping you just wade through the problems. And I think the problems will help. You can look into these in more depth, but I think it's a little confusing when you just try to prove each one of these without seeing real problems. So we're going to solve this one first, 24x plus 36y equal 12. Now this is probably the most important part of it. It encompasses this idea of greatest common divisor. And so we're going to start off with GCD of 24 and 36. What's the greatest number divisible by both? It is 12, yep. So since it's 12, and this took me a while to figure out, but I think I got it, is if you took 24 and divided by the greatest common divisor, 12, you get 2. And 36 divided by the greatest common divisor, you get what? 3. Okay? Pick a solution, something that's going to work here. For example, let's say that y was 1. What do you have x to give you an answer?
Negative.
Yep. So if you had, and I didn't mean to pick the one they had, but it works. 36 minus 24 is going to be 12. So that's a solution. Here's your x0, and here's your y0. Now, thinking this through, here's what I did. X is going to be -1. Okay. Then what's y going to be? Well, if x is -1, now we've got to look at all the other possible things, and all the other possible things are going to be 3 times t, where t is an element of the integers. Yeah. So think of it this way. -1 is going to work. The next one that's going to work will be a multiple of 3. Yeah. Yeah. You don't want to do a multiple of 2. It's kind of counterintuitive. No, it's a solution that I found, -1, 1. So this is going to be 1, and then it's going to be minus this multiple times t. Okay, why is it that? All right, let's go for it. So the first thing that we did is we said, all right, x is going to be 24, -1, plus 3t, plus 36, y equals 12. Okay, if we multiply through here, you're going to get -24 plus 36t plus 36y equal to 12. If you add this over, you're going to get 36. You get 36t plus 36y equal to 36. So 36y equals 36 minus 36t, and y is equal to 1 minus, oh, I did this before. Let's see, this is going to be 3. So this is going to be 24 times 3 is 72. I did this 72 in my practice. So this is going to be minus 72t, thank you. So this is going to be divided by 36 minus 2t. Okay? So notice what happens is when we take this greatest common divisor, 12, and divide it by a and divide it by b, what happens is that we're going to pair the opposite. -1 is going to pair with this opposite, and then the regular one is going to pair with this opposite here. And we subtract one and we add the other, because if you were both positives, this wouldn't be true. I know, it's a little weird. Let's try the next one, part B. It says greatest common divisor, 24x plus 36y equals 18. And is 18 a multiple of this 12? No, so there won't be any solutions. No solutions to that one. The next one, 24, 36, and 48, this one's going to work. So we're going to do this one together. Find all the solutions for knowing just t, finding all the possible solutions. So for part C, you have 24, 36, and this is equal to 48. Okay. The greatest common divisor is 12. Is 12 a multiple of 48? Or is 48 a multiple of 12? It is. So now all we have to do is come up with a new solution. Guess and check. What will be a solution for this one? 2, 0, yeah. And I know they used that one, but that's okay. You could, I think, could you do -1, 2? Does that work? Maybe. All right, so this is x0 and this is y0. So here's what we're going to do first. We're going to take 48, or yeah, you're going to take 24 again and divide by 12, the greatest common divisor. 36 and divide by 12 again. There's your 3 and there's your 2. So this one, x is going to be equal to 2 plus 3t. And then this one is going to be 0 minus 2t. I think you can reverse them. I'm pretty sure you can. Be worth proving, but yeah, I think you can. And just to double check, to show you that this is right, you have 24 times 2 plus 3t plus 36y equals 48. I'm going to get 48 plus 72t plus 36y equals 48. Then when I subtract 48, right? Subtract 48, you get 72t plus 36y equals 0. 36y equal negative 72t. What will y be equal to? Negative 2t. So we got it working perfectly. So these are the two solutions where t is an element of the integers, and you're good to go. So that's kind of the basics of it. There's a couple other different types of theorems that we use, but it really comes down to this idea that you're trying to look at divisibility with the greatest common divisor, and it is helpful to know what that greatest common divisor is. And it's always helpful to know if you get a 1, because what does that mean? They're relatively prime. There's no greatest common divisor other than 1 between them. So Euclid's lemma is if A divides B, C, and the greatest common divisor of A and B is 1, then you can say A divides C. So let's say you have 5 divides 3 times, let's make C equal to, yeah, it would 10 maybe? Okay, so if A and B are not divisible, don't have a common divisor, does 5 divide 30 though? Yeah, and so that's what this one's looking at. And it's actually a pretty easy one to prove. So let's go right to the assignment. We're going to launch into a bunch of these. Don't be surprised if we get most of this homework done, because I think you're going to understand it through these homework problems, and they're pretty good.